Okay, well, this is Unit 6, Day 6. And before I even get started, I want to say that today we're going to solve equations. So we're solving fractional equations. So now there's an equal sign, and now you have to solve and tell me x is 5, x is negative 2. But every single one is going to be on a must check. Why must you check it? Because anytime there's fractions, you're going to reject the undefined answers. Okay, so I want to instill that in your brain right now that this is also on our must checklist. Okay, well, example 22 says use the technique of cross multiplication to solve each of the following. So this is like old school, middle school. When you have a fraction equal to a fraction, just cross multiply, but I would make sure that you put parentheses around any binomial so that you remember to distribute. So if I cross multiply this way, I'm going to get 5 times my 4x plus 5. Don't forget the equal sign. And then when I cross multiply this way, I'm going to get is equal to 2 times the whole quantity x minus 1. So now I'm going to distribute. You guys should be very, very good and quick at this, but I'm going to get 20x plus 25 equals 2x minus 2. Okay, so now I'm going to minus 2x from both sides. And then this is just solving a simple multi-step equation. So I'm going to get 18x plus 25 equals negative 2. I minus 25 from both sides. And I'm going to get 18x equals negative 27. Divide both sides by 18. And I get x is equal to negative 3/2. Okay? You can check this. Now, you could check it for correctness. Now, to check it for correctness, you can store your value as negative 3/2 and then set the original equal to the original. It's going to tell you true or false, so you at least know if your answer is right. This is not going to get rejected because if I get rid of my colors here, 2 and 5, you plug back in, they're only falling in the denominators. There's no way there would be an undefined in this denominator because there's no x value down there. Okay, over here on part B, there are x's. So if you were to get a positive 2, 2 minus positive 2 would have you rejecting a solution of 2. Over in this fraction, if you were to get a positive 6, 6 minus 6 would force that to be undefined, so you'd have to reject that. So if you get any solutions that are positive 2 or positive 6, you'd have to reject them. Okay, that's the must check right here. Again, this one has no must check because there's no variable in the denominator. Okay. All right, so ready? Cross multiplication. This one's just got a little bit more algebra. So I have x plus 1, times the quantity x minus 6 is equal, so that was this way, and that is equal to 2 times the entire quantity 2 minus x. So on the left side, you have to FOIL or use the box. Okay, so you should be very fluent with this right now. I'm not going to do the whole first, outer, inner, last, but you should be able to get the same thing I'm getting right now. So you're going to get x squared minus 5x minus 6. And then after you distribute, you're going to get 4 minus 2x. Okay? In your head, you should be thinking trinomial. So I'm going to move both of these over here at the same time. Why? Because I'm setting it equal to 0. So I'm going to get x squared minus 3x minus 10 equals 0. I'm going to factor that. And I'm going to get x minus 5 and x plus 2. Split down the middle. X is equal to positive 5, and x is also equal to negative 2. Now remember, if you check this, 5 is okay, so I accept it, and a negative 2 is also okay. Okay, you would just have to reject a positive 2, because a positive 2 would cause that denominator to be undefined. All right, example 23. Not so easy. You can't just cross multiply. Why? Because it's not a fraction equal to a fraction. So I might go back up top and say that cross multiplication can only be done if it's one fraction equal to one fraction. Okay? And then when you look at example 23, you have a fraction minus a fraction equal to another fraction. So we're going to use the LCD method. Okay, so kind of like yesterday's lesson, you need to come up with an LCD for those three denominators. So 2, 4 can both go into 4, and there's at least an x, so my LCD is going to be 4x. Okay, there's no difference between 4x and 4x over 1. So now I'm going to multiply each piece by that LCD. So part A is just identifying your LCD as 4x, and then I'm showing you that 4x over 1 is the same thing. Okay? So I have the original. I have 1 over 2. Be careful here, guys. See how that's a negative? So it's plus negative 9. So I'm going to multiply everything by 4x over 1. So here's 4x over 1. And then I have a plus another LCD of 4x over 1 times my second piece that was given. Okay, remember that's a negative 9 over 4x. And then that's equal to this last piece they gave me, 3 over 4x, again, multiplying it by the LCD of 4x over 1. Okay, so look, blue boxes again. Now, you can cancel any top with any bottom. So this is just like your complex fractions here. Okay, so 4 and 2 reduce, leaving a 2 up top. So you have 2 times x times 1. Okay, so 2 times x times 1 would be a 2x. The bottom, you have it over 1 times 1, so this whole first blue box reduces to a 2x. The second blue box, the 4x's are gone. Okay, you could do them separately or together. And you're really just left with a 1 times negative 9 all over a 1 times 1 times 1, so you're left with a big minus 9. Carry the equal sign down. And the same thing in the last box. The 4x's cancel, and I'm really left with a 3 times a 1, which is 3. This crazy looking fraction minus a fraction equals another fraction is a simple multi-step linear equation. Okay, so now what do? I add 9 to both sides. I'm going to get 2x equals 12. Divide both sides by 2, and I get x equals 6. Make sure you check this. 4 times 6 is 24. 4 times 6 is 24. Nothing to plug in here. We accept the 6. Okay, so 6 is my answer. Okay, hopefully that's not too bad, just like complex fractions. Same thing over here again. Okay, so you want to do an LCD method. Okay, the only other method you could do, okay, and I guess I could do it with this one, is turn them into single fractions. Turn that into a single fraction. Alright, so how do I turn that into a single fraction? You have to get common denominators. So, I need a common denominator. 6 and 10 would both go into, I think, 30. If you said 60, that's okay, but then you'd have to reduce it. But they both go into 30. So now you're going to say, how does 6 go to 30? I times it by 5. So I'm going to multiply the top by 5, and I'm going to get 5x minus 20. Okay, the second fraction, how does 10 go to 30? I multiply them by 3's. And when I distribute that, I'm going to get 3x minus 6. Okay? Keep and carry the 30. Once you get 30, now you have to combine like terms in the numerator. So 5x plus 3x is 8x. Negative 20 minus 6 would be negative 26. And then that's equal to the original right side, which is 31 over 15. Okay? Now that you have a single fraction equal to a single fraction, you can just cross multiply. Okay? So when you cross multiply, you're going to do 15 times the 8x minus 26, and that's equal to the 30 times the 31. Okay? And 30 times your 31 is 930. I just kind of, well, let me write it out for you. Okay? So distribute. 15 times 8 is 120, so it's 120x, minus 15 times 26 is 390. See how these numbers are huge? And then again, 30 times 31 is 930. So now I'm going to add 390 to both sides. And I'm going to get 120x is equal to 1,320. Divide both sides by 120. and I get 11. Okay, check all your fractions, nothing to substitute in, you accept the answer. Okay, so it's just another method. So you would want, now look down here though, if you look at B, you'd have to get this B to be one fraction, this to be one fraction, and then cross multiply. That's why LCD method is going to work a little nicer. So now you have all your fractions, or denominators. You have 10x, 5x, x squared. So my LCD, 5 and 10 definitely both go into 10. X and x squared, you always take the highest. You need x squared. You need at least 2. You can't have 1 because the one that is x squared can't go down to only an x. Okay? So my LCD is 10x squared. Don't forget, guys, there's some negatives here. So that's going to be plus -1 plus -2. So I'm going to rewrite the whole question, multiplying each piece by that LCD, which is 10x squared over 1. So I get 10x squared over 1 times the first part, which is 1/10. And then plus 10x squared, my LCD, over 1, times the second fraction. The second fraction is -1 because we changed the sign, over x. And that's equal to this last part, which is -2. Oops, it's not -2. It's 1 over 5x times the LCD, which is 10x squared over 1, plus the last piece, which is -2 over x squared times the LCD, which is 10x squared over 1. So we have 1, 2, 3, 4 blue boxes to reduce. Okay? If you do it right, all the fractions are gone. So the 10s both reduce, leaving behind 1s, and I'm left with just an x squared times a 1 is just an x squared. Second blue box, x and x squared. Be careful. There's an x left up top. So now I really have 10 times x, which is 10x, times a -1. So 10 times x times -1 would be minus 10x. Okay? Carry down the equal sign right here in the middle. Bring it down. And now I'm going to reduce the third blue box. Okay? The 5 and the 10 reduce to 1 and 2. And the x and the x squared leaves an x up top. So now I have 1 times a 2x, which is just a 2x. Okay? Last part here. Last blue box. Your x squareds cancel, leaving behind 1s. So I really have a -2 times a positive 10, which is minus 20. Look at this crazy fraction minus a fraction equals a fraction minus a fraction. It's now just a one-step equation. Noticing that there's an x squared, you should think trinomial and move everything to one side. So I'm going to minus a 2x over, but I also have to add a 20 over. Okay? So x squared gets carried down. A negative 10x minus the 2x will be minus 12x. And then don't forget, you have this plus 20 that you just add in there. And now it's set equal to 0. Now I have to factor that trinomial. So I'm saying what two things multiply to 20 but add to a negative 12? It's x minus 10 and x minus 2. Because a negative times a negative is a positive, but negative 10 minus 2 is negative 12. Split, I get x is 10, and I get x is positive 2. Okay, again, make sure none of these values force that to be undefined. So if I go back up top, that's just a 10, that's a 50, and that's a 100. It's still not a 0, so you would accept 10. Checking out 2 for making sure it's not undefined, that would be a half, or negative a half, I should say. That would make that denominator a 10, and that would make it a 4. Still not a 0. I accept them both. Okay?